So I just found out that you and I are joining a small team to develop the new exit polling application. Okay, obviously this isn't true, but play along with me for a moment. Now, the team we're joining will have 6 developers, and each of us will be working remotely. I'd like to share my phone number with you and the rest of the team so you can reach me if I'm away from my computer. So, how should I share my number with you and the rest of the team? Let's keep it simple. We'll just use a markdown formatted text file and put it on a server that each of us can access. Hey, by the way, if you're thinking to yourself, James, why are you talking about such a trivial thing? Well, I've got a point to this little thought exercise, so just hang with me for a few moments. Okay, now imagine that a few months have passed, and Tom, one of our teammates, has moved across the country and he has a new phone number. So Tom hops on the server and updates his phone number in the phone list text file. Wait a minute, that's not Tom's phone number that's getting updated. That's my phone number. Well, that kind of sucks. Okay, now imagine a week later, in the middle of the night, the app we're working on breaks in production, and you're the on-call developer. Okay, so you start troubleshooting, but you're having a hard time figuring out exactly what the problem is, but you've narrowed down the problem to code that I've been working on over the last several weeks. After about an hour, you decide you've got to call me to get some help. So you open up our shared phone list file, and you look up my phone number and you make the call, but surprisingly, Tom answers. Oh, hey Tom, I'm trying to get a hold of James. I guess I must have dialed the wrong phone number. Sorry about that. Okay, so you look at the text file again, and you double check the number, and you make the call again, and you get Tom again. Dang it, the phone list appears to be screwed up. This sucks. How are you going to get a hold of me? In this moment, you're probably wondering, how did the phone list get screwed up? Who changed it, and what did it look like before the last change? I think this is a pretty decent example of one of the problems with mutable data. It's a silly mistake that Tom made, but it's pretty painful because you can't get me on the phone to help you figure out what the problem is. So, what could have been done to prevent this accidental mistake that Tom made? Well, here's a pretty low-tech idea. What if instead of using this shared mutable file, we just shared phone numbers over something like email? If we shared phone numbers via email, there'd be no way for Tom to accidentally change my phone number because you'd have your own copy of my phone number in a message that Tom couldn't get to. Here's another possible solution. What if we used Google Docs to maintain and share phone numbers? The nice thing about using a Google Doc is that there's a change history, so you can see who changed my phone number, and you can see what it used to be. Google Docs are kind of like immutable data in that when you change a document, you're essentially making a copy of the document and editing that copy. Now, there are trade-offs between using a plain text file and a Google Doc. Google Docs have more overhead because it's got to keep copies of all the different versions of the document as it changes over time. But let me ask you this. Are you really concerned about disk space with Google Docs? I doubt it. Storage is cheap, and it's not something most of us worry about. Here's another question. If we kept our phone list in Google Docs, and we made 10 changes to the document over a year, do you think Google Docs actually keeps 10 complete copies of this document? I doubt it. There's much more efficient ways of appearing to keep copies, but in reality, just storing the changes from one version of the document to the next. Okay, let's turn the discussion back to programming. Imagine you've got a list of phone numbers, and you pass this list into some function. Now, here's 2 options I want you to consider. Would you be okay with this function mutating your list of phone numbers? And I don't mean as a return value, I mean mutating the list in memory without you knowing about it? Or would you rather it was impossible for this function to mutate your list of phone numbers? I don't know about you, but I've been burned by the first option before in languages that allow data mutation. In other words, I pass some data into a function, not expecting my data to change, but that evil function mutated my data. So you know what I started doing? Often I'd make a copy of my data and pass the copy into functions to keep them from doing evil things to my data. You know what this is? It's kind of like manual immutable data. You could even call it a poor person's immutable data. Now, with Elixir, you don't have to do things like this because it's literally impossible to mutate data in Elixir. I bet some of you are thinking, this immutable data thing must be horrible for performance. I know I had this thought when I was first learning about immutable data. Let me respond to that thought with what I think is an interesting bit of Erlang history. The first version of Erlang was largely a modified version of a language called Prolog. Data in Prolog is immutable, so by default, Erlang started off with immutability. Now there's an old mailing list post from Joe Armstrong, the author of Erlang, that's quite telling. It seems Joe initially thought immutability might at some point pose a significant performance problem in Erlang, and he tentatively planned to add mutability to Erlang if and when it was needed. But the thing is, he never actually needed to. The performance of Erlang was always good enough. Keep in mind the time frame I'm talking about in this little story was around 3 decades ago. Think how much better hardware is today than it was 3 decades ago. So if the performance was good enough back then, it's probably good enough today, right? So the bottom line is, yes, immutable data is less efficient than data that can be mutated, but it's not horribly inefficient, as you might think, and in practice, its performance is good enough for all sorts of problems. Now, to be clear, there are certain types of problems that Elixir and the Beam just aren't good at, such as scientific computing, where lots of number crunching is occurring. But for things like web applications, Elixir is one of the best choices possible. You remember several videos back when I talked about shared memory in sequential programming languages? If you recall, I walked you through a fictitious scenario where multiple threads were updating and reading a record that was shaped like this, and we talked about how shared data like this is problematic when 2 or more threads are reading and or writing to this data at the same time. Let's consider this same scenario, but instead of using mutable data, as we discussed several videos back, let's say this data is immutable. So imagine a request arrives at a server and it fetches this data, and instead of mutating this data, it creates its own copy of this data, and at the same time it increments this count. But before it's completely done updating the count, the second request arrives, which just needs to read this data, but this time, since the data isn't being mutated, there's no chance of fetching this data in an invalid state, because it's never in an invalid state. As you can imagine, using immutable data prevented one of the threads from accessing data in an improper state. Now, you might consider this data to be a bit stale because a fraction of a moment later, this count will change. Stale data isn't ideal, but at least nothing crashed. Let's consider another scenario. What if 2 requests arrive at the same time, but this time both requests are update requests? The first request should update this count, and the second request should update this count. Okay, so the first request has its own thread, and it makes a copy of this data and updates the appropriate count, but at the same point in time, the second request makes a copy of the data, and it updates the other count. Do you see where this is going? Next, the first thread's updated copy of data replaces this data, and then a moment later, the second thread's updated copy of data replaces the value that the first thread just put back in memory. Do you see the problem here? The vote from the first request wasn't counted. It got wiped out by the second request. Okay, so what's the takeaway here? Well, immutable data can help us, but even with immutable data, we've still got potential issues with concurrency. So do you have any thoughts on how to fix this particular problematic scenario? I'll give you a hint with a little thought exercise. Let's go back to our fictitious story of you and me working on a small team of developers. Now imagine all 6 of us are on a phone call, and I ask you to write down each of our phone numbers in a Google Doc. Okay, are you ready for the phone numbers? Here you go. or
517-895-012153.
Okay, did you get that? Of course you didn't. You can't listen to all of us all at once and understand what we're saying. So what are you going to tell us after hearing all of us talk over each other? You could say, hold on, each of you talk one at a time, which is kind of like locking, which we talked about a while ago. Or what if you just said, how about each of you send me a message with your phone number and I'll get them put together in a Google Doc? Which one of these options is better? Well, I don't really like the first option because we're waiting on a phone call, listening to our teammates share their phone number, which I'm probably not going to remember anyway. I'd prefer the second option because it's less wasteful. Nobody has to wait around on other people. It's way more efficient. What I'm describing here as a solution is kind of how Elixir and the Beam works. Now, I'm sure you've got more questions like, how exactly does this work in Elixir? Well, hold that thought for now. I'm going to answer the questions you likely have in due time. For now, I just want you to realize immutable data is quite helpful, but it doesn't solve every concurrency challenge you'll have. Immutable data is one part of the concurrency solution. The other parts of the solution, well, I'll cover them as the course continues. A few videos back, I started using variables in IEX, but I didn't give you a proper introduction to variables in Elixir, and that's what we'll start to cover in the next video.